just get the show on the road, and then people will join as we go along. So hopefully people will join in the next few minutes. But let's just start. Okay, morning all. We're just gonna do a quick recap on study unit 4 and 5. Basically, for your assignment 2 that needs to be handed in, I think the due date now is Monday. So let's just do a recap on that. So what I have included is some of the assignment questions that was posted around some of the areas. I've included some of last year's questions. I've included 1 or 2 questions that people have sent me out of textbooks as well. Then you will see what I've included for you is, and again, I'll make a PDF of this afterwards and also put it on our WhatsApp group. And if you're still watching this and not part of a WhatsApp group, you can just send a WhatsApp to me and I will add you to the group. But basically, this is for assistance for you in when we see some of the words that we use in some of the questions. So I think this is quite a nice table just for assistance for you guys. That so it is in a slide pack. Like I said, I'll do a PDF that you have it as well. But I think this is quite a nice one that I got from somebody last year. So it does really nicely explain all those words that sometimes you look at it and you wonder, is it small or bigger? Is it smaller? Is it between? Is it so even if I use words like inclusive and exclusive, we have it now in this table as well. So just another one that, please, in the exam, in your assignments, print this, have it with you. It does help a lot. I know, especially when you again pressed for time in these kind of things. So we have it now on the pack as well. So yes, I think some of you did send me some of some questions that you were struggling with while you were doing stuff and couldn't understand why it's wrong. So just again, rather send it just to me than on the group. But if when the assignment sessions, the due dates are done, then you can share on the group. So just that nobody gets too much in trouble for that. But I thought this would be a nice way also to just do a recap. So I've just done a few, and some of it comes from other places as well from last year. There's one that I'm going to share, put on my Excel to share as well. So okay. So let's look at this question. So it's about probability. So there's a few things that you can always get in probability. So they can ask you to work out what the probability of one or the other. They can ask you to work out the and. What they also sometimes, or not sometimes, they do a lot, they would tell you something is mutually exclusive. Then you need to know if it's mutually exclusive, how does the and look? Or they can tell you something is independent, then you also need to know how does the and look. So this was one of the questions, and let's just, like I always like to highlight. So if you look at this would add up to 1. Okay, so they have already worked out for you what the probabilities are. So if I would have asked you what's the probability of, I don't know, even, I think that was even a, so just C is gender, I don't know, let's just say it like that, and low. So what is the probability that those two will happen? Then it is 0.76. Okay, so this is already in a probability table that you can just read off. So obviously what they do is they make it a bit more difficult. So they ask you, what is the probability that somebody is moderate given that they are transgender? Okay. So how would you guys have worked this out? So I think this was out of one of the assignments that you're busy with. So how would you work that out? And what would you have said is the right answer? Because here we now have a few answers. So how would you have done it? If this was now you in your assignment, what would you have done? Any clue or not really a clue? So you can just give thumbs up, thumbs down. So thumbs down, I will show. Thumbs up, somebody can assist me. So thumbs up, thumbs down. Oh, I don't think there is a thumbs down on the to show. Okay, so a lot would probably have said, okay, there it is, there we go for that. But that is not correct. So if the question was, what's the probability that this person is transgender and moderate, then it would be 0.01. Okay, but we're not looking for that. So remember, if we have probability, so for this one, much easier to write out your statement. Probability of moderate and transgender is the probability of moderate and transgender. And how I just remember it is divided by the probability of the second one. Okay, so that is your, and as we are doing this, remember again, you have 3 attempts to the assignment. So again, a third attempt was also. So moderate and transgender is 0.01. Probability of transgender. Okay, so we don't have a total yet here. So we need to work out the total. So the total was 0.05. So the probability of moderate given somebody is transgender is 0.01 divided by 0.05. Okay, and that is 0.2. Okay, and the reason why I'm using some of the things that you are busy with in your current assignment is also in the exam, your assignment point doesn't really matter. So for me, it is that you understand the work. So you will see I'm also very lenient on when you guys ask when it's assignment time. So it's, for me, it is you when it comes October, November, you need to know how to do the work, and rather use examples that are practical, that you struggle with, so that you can see how it's done. So very easily to make that mistake of saying, because it's transgender moderate, it is that one. But remember, we're working out moderate given transgender. So that formula is important because that's the and divided by the 1. So that gives you 0.02. So that's again why in your assignment, I don't know yet if it's going to work like that in the exam as well. If you selected that, you would have probably gotten 1 mark. So that is just how our prof set it up. So you would see 0.08 is probably, okay, it's not if you added that, so 0.05 if you added, so that might have given you something. If you add all of that up, it gives you 0.01, so that might have given you a mark. So it's nearly how you would have worked it out that there are possibilities that you can get a mark or not. Okay, so that's pure probability. Very difficult to put this on Excel. Let's just be honest. This is something that one needs to work out via the formulas. So let's go into discrete probability. So what I've done is, this was from last year's assignment. So when it is purely, and let's just make it a bit bigger, when it is purely looking at the table and we're asking probabilities around it, again, you need to work through it. But when we now get to, I've got one on Excel where we do expected value and standard deviation and things like that. I'll show you all just after this one how we can do that in Excel. So probabilities of a discrete that you need to do here, it's very important you need to look at this table again, because now we're going to see again, for me, words that if I see both are inclusive, I start wondering, and I'm just, again, English not my first language, so some of these words are really not words that one is used to. So that's why that table is quite useful for study unit 4, 5, 6, 7, nearly for all the other study units going forward. That table is quite useful. So let's look at the probability that 2 learners are absent on a given day is 0.2. So this is purely only 2 learners is 0.2 correct. Okay, so they're not asking more, less, anything like that. They're just asking 2 learners. The probability that between 2 and 5 learners are absent given a day, assume 2 and 5 are not inclusive. Okay, so let's just go to this one. X, so not inclusive, is exclusive, so we're not including those 2 numbers. So they say to us here, not inclusive, so it's exclusive, so we're not including 2 and 5. So we're only looking at 3 and 4. 3 and 4 is 0.3 plus 0.15, which is 0.45. Okay, so not inclusive. So let's do E now, because here we use inclusive. The probability that between 2 and 5 learners are absent on a given day, assume 2 and 5 are both inclusive. Okay, so now we basically include 2 and 5. So that is 0.2, 0.5. Okay, so it gives you 0.7. So just that difference between when it's exclusive and when it is inclusive, it very, very, very easy to make that mistake. And again, here they could have written it as probability of px, where x is smaller than 5, bigger than 2. So this is how they could have written it as well. So just also for the wording, so what's the probability of x here, where x is smaller or equal to 5. So this is your inclusive. So again, just, and then they can do a combination of that where one is inclusive and one is exclusive as well. Okay, so then let's look at the probability that at most, let's go to that. Where is at most? At most, smaller or equal to. So at most 2, what's the probability that x is smaller or equal to 2? See, now it was easy. I didn't really need to worry a lot. I just went to that table and I used it, and then smaller or equal to 2. So let's just, so it's 0.1, 0.3, 0.5. So that is correct. So let's look at the last one. The probability that at least, let's go, at least, where at least bigger or equal to. So what's the probability of x bigger or equal to 2? Okay, so now luckily written that, so very easily again to make the mistake to say, well, there it was 0.5. So the opposite should also be 0.5, but remember now it is bigger or equal to 2. So it does include 2. So it is that area, which is then 0.7. And very interesting is, now look at, we've written that down as a function, or as how it could be written as a probability. These two give you exact the same, and look at how I marked it, the blue and now the pink, exactly the same. So again, there is not just one way of asking you a certain probability, and that's why it makes it so difficult to do this again in Excel, because there are really a few ways to do it. But what I want to show you in Excel, so let's do it in, and I haven't, so this is the formula that has been written up. It is there in the background. So here, all that you do is you change, and so there's your x's, So if you have an extra one, you just put it in. If you don't, you leave it out. If you only have 4, you just make those two empty. So all depending on how much you have. So we have 5. So let's just look. There's 0, 1, 2, 3, 4, 5. And let's put in the probabilities. 0.2, 0.2, 0.3, 0.15, 0.5. Okay, so we've got the probabilities, and now this function have calculated already what you, so you would, if you look at how you would have done the discrete, we would have said that times that gives you, so that is exactly what this function does. It sums it at the bottom, so there you would see the sum. So that is, if we need to get the expected value, it is there. So why is this not the same? Which is quite interesting. So let's just check what is happening here. Now, grade 9. Calculate the expected value of number on a given day and choose the correct answer from the list. 0.1, 0.2, 0.2, 0.0. Oi, that one was wrong. Yes, Ian. Or did you want to tell me that's wrong?
I put 0.5 instead of 0.05.
Cool, thanks. Yes. And so that is the other thing. Please, Anna made that a mistake. So it's easy to make a mistake now with a number. So corrected it, answer 0.35, and there it is. Okay, so much easier to use this now. Then what you need for your variance is calculated. So there's your variance. And if I would have asked you your standard deviation, it is there as well. So there's your 3 measures that you can just use. And it is labeled discrete in the Excel. So it's much easier for you guys now to use this than really going another route. So again, this is just another tool. I will share it again on the WhatsApp group that you can use. You will see there is things on study unit 3, but it's study unit 3 is very difficult in a sense to really put a template together. But from study unit 4, very easy in a sense to put a template. So if these numbers were a bit different, let's say those two were swapped around, as easy as that, you just change it and you would see that your answers differs then as well. So for me, this is really a nice tool just to work with, and you will see it goes up to, you will never get 16, a sample of 16 or something like that, but just to give you some extra if you need to complete it. Another tip on this is just make sure, so if you only have 4 and you then just make sure that you take all of these out, because now suddenly there is still a variance being calculated because it does see it as 0. So just if you if it's working with less than what is in here, just make sure that the rest are 0 so that you don't get in trouble when you get to the final answer. Okay, does this seem like something that can work for you guys? I'll do Binomial and Poisson as well now, so I'm just hoping that this is something that you guys can really make it easier for you. So please, now even in, like I said, you still have a third attempt to your assignment as well. So even if you did good in the first two, um, just do it again with this and see on timings and things like that, if it works or not for you. Okay, so let's go back to the presentation. So this was the interesting one because if you look at the word, this is really confusing. So if and this is purely a definition. This is a definition question where it wanted to catch you out. Okay, so if E denotes an experimental outcome of probability of E, its associated probability, using just big words here. So what is the probability that can be linked to it? Which one of the following probabilities does not meet the basic requirements? Okay, so we know any probability is from 0 to 1. So this one, you just needed to look at which one is not from 0 to 1. So that's 0, that's fine. That's 1, that's fine. 0.9 is still smaller than 1. 0.5 is. So the one that can't be a probability is 1.1 because that is more than 1. But where I think what makes it difficult is now they're using, I first look at that associated and I'm like, what the heck is going on in this question? But actually they're asking you which one does not fit the probability rule. And the probability rule is that anything between equal or so from 0 to 1, that can all be a probability. So basically the one that is wrong is for 1.1. Okay, so it could have been put in much simpler language. And I can see here's something. So this one will also be much less weight than if this was for previous last year's assignment. So this one will be a much smaller weight. So you can see it's 2 marks. So here you probably will also not get 1 out of 2. You will probably get a 2 or 0, where in this one, if you did something wrong here, probably would have gotten 1 mark. Yeah, so definition that you needed to do here. Questions up until this point. I am going quickly because I know my power is going off at 10, but just quick, any questions thus far? Okay, cool. Let's go on and you can stop me at any point. Okay, so yeah, what I've got, there's some wording there about inspections. The inspector knows from past experiences that 8 out of 10, so I'm just writing numbers down yet. out of every 10 new built houses will comply with municipal regulations. Which one of the following statements is incorrect? Sure. So it's interesting. I don't know if there was anything else there. Okay, so the building houses comply or not comply. So that's basically your two things that happen. So if it's comply, not comply, we don't have any timeline. So it's not built within a day or a minute or a month or a year. So then we know we're working with binomial. Okay, so the experiment can be described as a binomial with 10 identical trials. Oof. That now, I would have said yes. Please just check that wording. I'm always worried if I throw in definitions. I don't have my textbook now with me, but just check that wording because I'm always worried when they add extra wording like that. Let's just go to the next one. Two outcomes are possible. So yes, two outcomes are possible for each, and it's comply with regulations, which is a success. Don't comply with. So there I said it, yes or no, binomial, so that is also correct. So we're looking for the incorrect one. The probability that a newly built house complies with municipal regulations is 0.8. And this person said that one is wrong, but if you look here, the inspector knows from past experience that 8 out of 10 is 0.8. Okay, so that one is unfortunately also correct. The expected value of newly built houses that will comply with municipal regulations is. Okay, I'm just marking that. Binomial, expected value of binomial is, what is it, n times p, or n times, depending on what they give us. So we know what n is, it's 10. We know what p is, that was what is there, so that is times 0.8. So 10 times 0.8 is 8 and not 8.8, so that would have been the wrong one. Each inspection constitutes a trial with independence, so that is also correct. So the things that, so for me it's interesting that that one was the wrong one. The things that I would just, and that is, please have your, when you do this, your textbook with you. Things like what they're including here, institute a trial with independent results from each other. That is normally where they also try to catch you out with those wordings. So I would not even have expected it to be one of those two that was wrong, because this is actually, it's again, if you mark that wrong, this one would have been wrong in any case. So because then you wouldn't have known what the P is and how to work out your expected value. For this, again, very difficult to use Excel, but let's look at what is in Excel. And you can see here I've also put in the table just as. So let's see, what did we have? We had N10 and we had the probability 0.8. So if I set 10, I set 8, um, again, 0.8, not 8. There was the mean was calculated there. So you could have used this as well to calculate the mean. If I actually ask you the variance, it is there. If I ask you the standard deviation, it is there. Just wondering what this referred to. So that was something else that was tried to work out, but don't. So that refers to if you would have used the tables. Okay, so you could have used this in this instance as well. I'm just going to go back to what it was, because it was specific to, if you look then at all of these, because what we are going to use this for is the next question as well. So I want to use it for the next question as well. But here you can, and let's highlight that is where you could put in your two numbers, so the 10 and the 0.8, and it would have calculated your answer. So let's just put that in a lighter. This was a test just to make sure that the top was right. Okay, so again, how you could have done it in this Excel, just some of the other answers obviously will not be available, but to do your expected value, and if there was a variance and a standard deviation, you could have used this for that. Okay, so just again, if you want to use it, it is there. I think I've put this nearly on a lot of the spreadsheets so that one can just always refer to it back again. Okay, so again, how to use the Excel if need to, for binomial. So let's just check what the next one was, and this one was a weird one, and it was in last year's assignment as well, because if you look at what we've done here, that was last year's assignment where we've looked at how to look at the question. So definitely it was in last year's assignment. That's why I'm just showing it again. It's in this year's assignment. It was in the exam as well. So this is something that again, where I said don't worry about the formula, how to use it, but in this instance, it is looking at the formula, but replacing the formula with information. Okay, so let me quickly, where was my, sorry, I'll just want to open up where my last week's study unit was, that I get that formula page. Just want to copy that in so that we can use it. I think it was session. Let's just check. Okay, so we know it. Okay, so let's see if I can. This whole thing will probably now copy, but that is also fine. We will make a plan. Okay, let's just make it a bit smaller. Okay, so basically what we are doing in this one is we are looking at a binomial, and we need to nearly populate this formula. So very, when you look at it, it's very confusing. When I looked at this, I was like, what the heck is going on here? So, and that is where I now again want to give you tips, because what we'll see, so look at all of these ones, all the same. So all your answers are exactly the same. So if we look at this, that will be part 1, that will be part 2, and that will be part 3. Okay. So look here, 10, 15, 15, 10, 10. All of those are the same, so we actually know then from this it's 0.8 to the power of 5. But let's just, so I haven't looked at the question even at all, so this is just what I'm picking up. So then I pick up here's 15 and 10. So something here tells me I know that x is 5 because x was there 5. I know here that was 0.8, so that is why this is 0.2, because it is 1 minus 0.8. Okay, so if x is 5, there I can put in a 5 already. That will be also a 5. Okay, so let's go to the question because I don't know what n is. Consider the building inspector's visit again. So it was coming from a previous question. Suppose now that 15 new built houses are selected randomly. So n is 15. Okay, so n here we would know now is 15. N here is 15. So, and then n is 15. So 15 minus 5 is 10. So that is not the option. That is not an option. Okay, so we've eliminated 2 options already. So now we're sitting with that one, that one, that one. If I look at the 2 that I've eliminated, so this is again purely out of, I haven't done anything yet. It looks like there's one that looks the same, and there's one that looks the same. So if I was in the exam, just by looking at certain info without working out that yet, I would have probably said that one is also incorrect. So if I needed to, at this stage, guess, I would have guessed between the first 2. Okay, but that is just out of how I'm now eliminating, but that could probably also be the right answer, but that is just purely how I did it now. So this, let's see if we can use Excel, because here, yes, you can use your calculator. 15 factorial, there is a function on your calculator. If you don't have it, what it means is 15 times 14 times 13 times up until times 1. At the bottom, you would have done it the same with a 5 up until times 1, and you would have, so that would have been that one, and this one would have been 15 minus 5 is 10, so it would have been, and up until 1. Okay, so a lot of calculations. Some of the calculators have this function on it. Not all of them does. Where it sometimes sits is also a place to ponder and look for. So let's see what I now have. I've got n is 15 and I've got my x as 5. So let's just quickly see if in this I can't maybe work it out. So factorial, it's already built in there. So let's just quickly see. It refers to that. So let's say n was 15. X was, what was it, guys? It was 5. Okay, so just by looking at this one, and I am going to change it back to the previous statement. N15, X5, there's that we need to work out. And let's just, sorry, this is very small. I hope that's bigger. So on your Excel that I will share, we've made N15, X5, and if we need to look at what was that function that we worked out, it is 3003. If we go to that, there it is 3003. Again, so by using the Excel, you could have gotten to that 3003 without too much of a work that you need to use a calculator. So again, if you haven't done assignment 2 for third time, please use the Excel that I will send after load shedding, and see if that works. If it doesn't work for you, don't use it. Use something else. If it works, please use it. Okay, so this was also one of those that you guys would have gotten in assignment. And remember, if you go back to my previous videos, I told you, no, don't worry, in the exam you won't get something that is not on the tables. 10 Poisson with 10.5 was not on the table. Okay, so, and then the scary thing that I saw here is very close, very close. Those two are very close. So if I look at those numbers, I looked at the where lambda was 10, and then it gave me, I think, that number. So it's very difficult from your table now to suddenly you would have needed to guess. So let me quickly go to, I just want to open that, and let's quickly, it's normally about page 120 or something like that. Okay. See, so your tables goes up until 10 and then 20. So what I looked at is, and they ask exactly for 10. So I looked at 10. So I looked at that, and I said, phew. Okay, here we go, here we go. So it looks like those numbers increase 1.251. Quite interesting, the 11 one that is. So I said 1.1251, 1.1251. So I would have, and I think that somebody else have guessed that as well. So that would have probably be, my guess is to say, okay, it's close to 10.5. I don't know really what it is, but let's see what's available in Excel as well. So if you look at Excel, um, and here we just put in the numbers to work out. So this is some of the tables that it would have worked out. So let me quickly see if we put in, what was it, 10.5. That wouldn't have worked, so let's just undo it. So we're working with Poisson. Okay, so let's see, what do they ask in this? X mean cumulative. So let's quickly get this function open. The X was, what was it, 10? The mean is the lambda, so that was 10.5. It is not cumulative, so I just want to see if we open this up. Okay, so let's do that. Okay, so here is your answer if you, so what was that question? 7 minutes before power goes off, so let's just, okay, so here is your answer to this question. So if you now get anything else, you just, and let's do it nicely. We put in, and that is what I like about Excel, is you can basically manipulate it as you go along. So n is 10, so we could, so for you guys, if you find anything else, you can just change these numbers and use it again. Okay, so lambda 10.5, n was 10, and that is your probability, so it would have been 0.1236. So it might be that Now you guys get in the assignment a different set of numbers. Just use that. And if you get it in the exam, let's just use this. So again, just something that, as you'll see, we just built onto previous work and work with that. And as you guys again send me, if you now do assignment 2 a second and a third time, and there's something that you're struggling with, or you see this is totally something that we haven't done in any of the classes, take a pic and send it to me. Because then we will go through it. If it's possible, I would put it in Excel. We can work it out, that if you get something like that in the exam, we know you'll get it right. Okay, here was one, again, Poisson. It was one of the examples in one of the study guides, I think. The average number of certain radios sold per day, Poisson with mean equal to 1.5. The probability that the firm will sell at least, so at least is big or equal to. So probability that you will sell at least big or equal to 2 radios. Okay, so lambda 1.5 big or equal to 2, lambda 1.5, lambda 1.5, let's just remember that, big or equal to 2. Okay, so big or equal to 2. So you would have needed to say all of that. I would just rather say 1 minus the 0.2231 and 0.3347. So instead of doing that, I would have said 1 minus probability of x smaller than 2. So 1 minus the probability of x equal to 1 plus the probability of x equal to 0. So it would have been 0.02231 plus 0.3347. Sure, and that would have been, let's race against time, 1 minus 0.2231 minus 0.3347, and I get 0.4422. And there it is. Okay, so basically, if you look at this, what I would have done is a way to make it easier, and that is to do a 1 minus. So yeah, that is how I would have done this one and not add all the rest. Okay, so let's just save before power goes off, if it now goes off. So I'm just stopping the recording as well, that I know nothing